Hi everybody, welcome to another video in Math 1324, section 2.2, elementary functions and graphs and transformation. So in this section we more focus on the transformation and not actually how to graph. So the transformation, pretty much we have some basic function like this and we will transform that somehow. Right, so we need to know the basic function so we're familiar with it, and then we can do other graph later. So the identity function, the function y equal to x, or we say it, f of x equal to x, and this whatever x is, y will be the same values. So, and one thing we notice that all of this graph equal to the point 0, 0, 1 and 1. Right. Now, quadratic function y equal to x squared. Cubic function, again we can write y equal to or x, f of x equal to x squared. It doesn't matter. A cubic function, just interchange. Or you can write y equal to x cubed. Square root function, cube root, and absolute values. So some function that go through -1 and 1. Some just -1 and 1. Some is -1, -1. Right. So those are the basic function. Right. Now what we do now, it will be the transformation of these graphs. Like I said, we focus on the transformation and not the graph itself. We might sketch the graph technically, but as long as we understand how the transformation works, it should be fine. Right. And take a look at this. So there are two different types of transformation, and the first two, I should say, vertical shift and horizontal shift. So shifting in general, shift in other book they say translation. So we could say it first. We say it shift will be the same as the translation. Right. So for the vertical shift, notice that we're going to add something to the function, and then we for horizontal shift we subtract. So you see that this distinction here is this is let's say the basic of x squared, and we add 2 to it. Now this is the basics is absolute values, and we add 1 next to the x. So this is inside, this is outside of the square, this is inside of the absolute values. So whether the square and absolute values is not really important. What important is that it is inside or outside. So in general, if it is, sorry, actually hit the line. In general, if it is inside, it will affect the graph horizontally. If it is outside, it will affect the graph vertically. So let me write that out. So affect the graph vertically. And if it is inside, so it affects the graph horizontally. Right, there's more to it. Notice that, as you see, it is plus, it will be up. If it's minus, it will be down. So that makes sense, as the y-axis positive is up and negative is down. So that makes sense. Now, the inside, I affect the graph horizontally. If it is minus, it would be to the right. So now this is kind of backward, right? If it's plus, it is on the left. Usually the axis positive on the right, negative on the left. So it's backward here. So as you see throughout this section, as far as transformation goes, if it is inside, it will be affect the graph in the reverse manners. So in general, that's how it works. Right. So let's see what's that right. Try to look for a pencil if I have one. I have a pencil here. Right, so first use the basic graph to sketch, and then use the transformation, of course. So first, the basic on the previous page. The basic here is the square or quadratic. Would look like this. Right, so that's x squared. Now we have the plus 2 to the graph. If we plus 2, that of course is a square, and we add outside the square, so it is outside, affect the graph vertically, and it is, if it add, it go up 2 units. So the point here go up 2 units. The point here up 2, this up 2, and we have the graph. So this is said to be y equal to x squared plus 2. Right. Next, we have to write down what is the basic graph. The basic here is absolute values of x. What we do is we'll add 1 inside. So what we have is the plus 2, plus 1. Now it is inside of the absolute values, so next to x. So anytime we modify inside a function, that affect the graph horizontally in the reverse manner. So conventional wisdom saying positive on the right, negative on the left, but it is reversed to what it is normal. So positive on the right, positive on the left, negative on the right. So this is 1 unit to the left. So we start with an absolute values, which is a v. And now everything 1 unit to the left. So this go to the left, this to the left, this to the left. Just say it. This is y equal to absolute value of x plus 1. A few more. And we combine both of those transformations. So when we look at this, first we see this is the basic is the square root. go like this. Now we have two components, -2, sorry, should keep the color code, the -2 and the +1. +1 on the outside with square root, right? So the outside affect the graph vertically. This context, it is up and down. So in particular, 1 unit up. -2. -2, it is inside of square root, and so it affects the graph horizontally. So it goes left or right in reverse manner. So that will be 2 units to the right. Reverse to what? Conventional wisdom. The x-axis positive on the right, negative on the left. You have to work opposite to that. If negative, it moves to the right. So in that case, we can just say 2 unit, 1 unit up and 2 to the right. So 1 up, 2 to the right. 1 up, 2 to the right. And then we have that. I said the graph is secondary. The important thing is, how do we write? How do we write the transformation here? Now we do this. The basic here is x squared now we have the +2 that is inside. So inside affect the graph horizontally. So it's add or subtract, so 2 units. Reverse manners, positive on the left. Move 2 units left. And -1. 1 unit down. So we start with a square. Quadratic. 1 down, 2 to the left. One down, 2 to the left. 1 down, 2 to the left. So that is y equal to x plus 2 square minus 1. Right, so that is translation or shift, moving left or right. The shape of the graph will remain the same. The next part, when we have stretching and shrinking, the shape of the graph will change. Right, now, reflection, stretching and shrinking. So compared to the graph of y equal f of x, the graph of y equal to a times f of x is obtained by multiplying the y values by a. So, and then we may have some numbers that is bigger than 0, is stretch, anything, right, it should be, sorry, it's bigger than 1, there's a typo here. If less than 1, it's going to shrink, so don't have to memorize that. Just in the English language, if we make something bigger, that means we stretch. If we make something smaller, that we shrink. Right? And if it's -1, it will be a reflection. So just flip it upside down. Right? So getting bigger, stretch, getting smaller, shrink. Just keep that in mind. Now, on this one, the basic is y square, x square. Look like this. And now we have 0.5 times it. So if we have 0.5 and we set multiply to y values, now if we have a positive number multiply by 0.5, we get something smaller. So if we get things smaller, that will shrink. Right, so how does that works? So it shrink, the y values get shrink. Now what is the y values of 0 here? Y up 0 multiplied by 0.5, so still 0. Now when y equal to 4 multiplied by 0.5, that down to 2. A negative 4, positive 4 down to 2. And then 1 cut in half. So pretty much we have kind of that. So that is y equal to 0.5 x squared. Now think about that. It's just like to have the graph, and then we shrink it vertically. Shrink that. We have the second graph. Y equal to negative 2 absolute of x. So of course the basic is absolute of x. That's v. And now we have the minus 2. So focus on two things. The 2. Just the minus and the 2. The minus, that's going to flip upside down. And the 2 is multiply y value by 2. And if we multiply by 2, that's going to be a stretch. So let's start with the v. And now there's two things. First we reflect or stretch then reflect. I stretch first. So whatever the y value is, multiply by 2. Whatever the y value is, multiply by 2. 0 multiplied by 2, still 0. 1 multiplied by 2 is 2. So we have the graph. But we're not done. Then we have to have the reflection. So we're going to flip this upside down. So this point going to mirror image through this line. So the point here will stay. This becomes here. So this is the graph. Y equal to negative 2 times absolute of x. Now let's put all of that together, and now we have the transformation of the series of transformation. Right. So we may have an a multiplied to a function, and then subtract something to x, or add something to x, and then add something to the whole thing. So just like order operation, inside and outside, multiply, divide, and add or subtract. So we have to take care of the h first, inside, and then outside, multiply by a. That could give us stretching, shrinking, or reflecting. And then inside, multiply, divide, add or subtract. So the k will be less. So that is the order of transformation. Like I said, I'm not focused on how the graph actually looks, but more important, what the transformation that we have. So in this case, the basic graph is square root, which look like that. Now we have few components. First, there's the -1, and then 2. Of course, inside and then outside. So -1 is the next operation. So that is 1 unit to the right. One unit to the right. And then 2. That y value is multiplied by 2. And multiply by 2, get a bigger number, so that will be a stretch. And order operation, that's the first one. Now we move, and now that we stretch. So move 1 unit to the right, 1 to the right, 1 to the right. And then multiply everything by 2. So y value here is 0, multiplied by 2, still 0. Y is 1, multiplied by 2, it's going to be 2. 2, that would be 4. So just move 1 unit to the right, then stretch up. And like this, the basic is a square. Have a few things. There's a minus, so that's -1 to that reflection. And there's a +2 inside, so that in affect the graph horizontally, but in reverse manner. So 2 units to the plus will be on the right, the left. So move 2 units to the left, and then we have the +1, which is 1 unit up. Right, so I'm going to mark on that. But next, the order of transformation. Just inside first, and then outside we multiply, divide, and then add or subtract. So that is the order operation. So first, we move 2 units to the left. 1, 2, 1, 2, 1, 2. And now we reflect, flip it upside down. So 2 units to the left, reflect, then 1 unit up, just move up 1 unit. Right, so that's what we have. Right. Now we have this. So we have the basic graph. We have not the basic graph. We have the graph of the function given like this. Now we just focus on the transformation. Again, there's a 2 here. So that means our y values multiplied by 2. Multiplied by 2, meaning that it's going to stretch. If it's less than 2, it's going to shrink. Less than 1, it's going to shrink. Plus 1 unit to the left. Minus 2 unit down. Right, so, and then all the operation inside, and then multiply, divide, then add or subtract. So I have to move 1 unit to the left first. 1, 2. And then multiply everything by 2. So y value is 1, multiplied by 2 is 2. Y value is -1, multiplied back by -2. 1, that's 2. Y value is multiplied by 2. So we have that. The 1 to the left, and then stretch, and then 2 units down. So 1, 2, 1, 2, 1, 2, 2. Right. Next we study about the piecewise function. Let this be the function. A piecewise function is the function that associated to the piece or the part of the function is the condition. If this condition is satisfied, we use that part of the function. If it's not, see if the other one is satisfied, then we use it. Right. Now f of 2. 2 is obviously when you substitute here at the bottom inequality, it will work because 2 greater than or equal to 1. So because of that, we're going to use the second part of the function. Now substitute 2 into x. That's 10. Now when we substitute 1 not less than 1, so the first one's false. 1 greater than or equal to 1, so yes. So second equation is still true. Put 1 in here, that's true. So we have 1 cubed plus 2 and 3. Now for -1, clearly it's less than 1. And less than 1, so we use that part. -2 minus 1 is -3. So that's what we have. Sketch the piecewise function. Well, just sketch the pieces. Focus on the part, this part first. X less than 1, we have y equal to -x squared plus 2. So -x squared plus 2 is, just want to quickly say this is the basic of x squared. The negative side reflected, and plus 2 will be 2 units up. So x squared reflected, so upside down, and then 2 unit up, but only for x less than 1. So this is 1. Less than 1 will be on this left. And we're going to graph negative. So that go up 2 unit and then reflect down, then up 2 unit, so go upside down, then up 2 unit. So it will be this. It has no equal sign, so the empty circle. Right, so we have that part. When it's less than 1, we have that open down and 2 unit up. Next, we have the square root when x greater than or equal to 1. Well, that's just 1 unit to the right. So the square root is this, 1 unit to the right. And this has equal sign, so this graph has 2 parts. It's called the piecewise function because they have 2 pieces of function. So for second part, it's just a square root 1 unit to the right. So just have that 1 unit to the right, and then the other one, the parabola that open down, and then 2 unit, then stretch, and then reflected, and then 2 unit up. Right now, still to part of the piecewise function. I suppose apply visual policy costs $15 for the first unit, and then for each additional unit. Let's see if x be the cost of x unit and what 10 unit will cost. So we said if it is just 1, it's going to cost $15. And it additional, we start 15 and additional, so we have to subtract from 1. That goes $4. Right? 15 for the first one, and everything after the first is going to be $4 each. So put them together, we have 15 plus 4x minus 4, so 11 plus 4x. This is for x greater than 2, greater than or equal to 2. So we have the piecewise function as 15 when x equal to 1, and everything else we have 11 plus 4x when x greater than or equal to 2. I would say when x greater than 1 if we want to. And the next part is evaluate at 10 unit. So 10, substitute to the condition, of course 10 is greater than or equal to 2. That gives us 40, 11, that's 51. That's what we have. Next, the instant utilities rate as follows. For the first 5, it's going to cost that per CCF equivalent 100 feet of natural gas. So we say it for the first 5. Meaning that if x is the usage, it will be less than 5. Let's say we can make it equal to, that's fine. And in that case, the cost is 0.7866 times x. The next part is the next 35. So original less than 5 now is going to be greater than 5. Make it greater than. But it have to be the next 35. So we start with 5. The next 35, 5, and then 35 will be 40. So this would no more than 40. Because that only the next 35. After the first 5, 35, that will be 40. Right. So in this case, the cost for the first 5 is going to be this much. And after that, the cost will be 0.4601. Now, if we multiply by x, that will be wrong because this is the additional one, additional after 5. So if we use 6, if x equal to 6, we only have additional of 1 after the first 5. So this is the rate, but only after 5. If there's 7 units, we subtract the first 5, there are 2. So we only, whatever it is, we have to subtract 5 multiplied by the new rate. And then for the over 40, that over 40, so the rate will be as follows. Regardless of the first 5, it's going to be at this rate. And after that, it will be at that rate. And then the new rate will be for anything that is more than 40. This is the rate. Only for the part for over 40. And put all of that together, we have the piecewise function. The cost function is 0.7866 x if x less than or equal to 5, and then 0.7866 x plus this that is for an x between 5 and 40. And then the whole thing here. X greater than 40. Right, that. And so with that, we finish section 2.2. As always, thank you for watching and see you in another video in Math 1324.